Hi, my name's Dave Latham. I'm here to talk about refining operational practices for controlling rabbits on agricultural lands. Firstly, I'd like to point out our collaborators, Otago Regional Council, in this project. And secondly, I'd like to point out my co-authors, Nugent and Bruce Warburton. So I'm not going to spend too much time on this slide. Most people in New Zealand are familiar with the problem with rabbits. They're introduced into the country, significant pests of agriculture and the environment. They were historically controlled by poisoning until the illegal release of RHD in 1997. However, their numbers are increasing again as the effect of RHD begins to wane. This has led to the need to reinstate widespread aerial poison control operations, most commonly with 1080, and that's a toxin I'm going to be concentrating on today. So I'd just like to play a quick video here, just to demonstrate the high number of rabbits that are out there again. Some of our transects from last year indicated that rabbits were getting up to around 250, 300 rabbits per linear transect, so they're really getting up to high levels again, comparable to what they were before the release of RHD. And that is leading to hillsides being denuded of vegetation and farm stocking rates really being reduced quite considerably. So I'd like to just take a second now to describe the current practice for aerial 1080 use. Currently there are 2 pre-feeds of non-toxic carrot baits sown at 30 kgs per hectare, 1 application of toxic carrot baits sown at 30 kgs per hectare. The baits are broadcast for complete coverage of the treated area, and there's about 1 week between each application. This results in a density of about 5,000 toxic baits per hectare, or about 0.5 baits per square metre for about 100 rabbits per hectare. So in other words, about 50 baits per rabbit. Now, as each rabbit only needs to consume about 5 to 10 baits to obtain a lethal dose, there is quite an excess of baits that are sown during current practice. So that's an important point to remember, and one that I'll get back to later in the talk. So if we look at that current practice visually, in an area of, say, for example, 100 hectares, a kilometre by a kilometre, you'll see that 30 kilograms of bait is broadcast across here to provide a reasonably even coverage of bait across that treated area. Now, this bait is most often sown using a fixed-wing aircraft, and the flight lines associated with the fixed-wing aircraft are represented by these vertical bars. And in order to get this broadcasting of bait in an area, the aircraft needs to fly flight lines that are 25 metres apart, and this results in 40 lines in a 1 kilometre area. So it's a considerable amount of flying, and it's one of the major costs associated with rabbit control. The costs are about $70 to $100 per hectare, so they're very expensive. So why do we need to sow 5,000 baits per hectare, and why do they need to be broadcast? Nugent and colleagues have recently reviewed this and determined that it was most likely because of poor bait quality, particularly highly variable bait size and toxicity. And so the high number of baits were sown, about 30 kgs per hectare, were sown broadcast to maximise the likelihood that all rabbits would encounter and consume a lethal quantity of bait prior to the onset of toxicosis, which is the stop feeding mechanism that's induced by 1080. And this usually occurs at about 20 to 30 minutes. So the aim of our work was to one was to reduce the per hectare control costs associated with the work, and then it was also to reduce the per hectare use of 1080. And the important thing is we didn't want to lose efficacy, so in other words we are interested in killing the same number of rabbits, same proportion of rabbits at least. And the way that we intended to do this was to increase the flight path spacing, which essentially would lead to a reduction in the amount of flight time associated with a fixed-wing aircraft doing a 1080 operation. And this would result in strips of bait being sown rather than broadcasting a bait. And in association with that increase in flight path spacing, we were also interested in reducing the amount of bait sown per hectare from 30 kgs down to initially 10 kgs per hectare. The requirement of this was improving bait quality, and Otago Regional Council has been very proactive in helping us with this, and they've really helped to improve particularly the size of the bait, producing a far less variable bait size. There are improvements that can be made, but they've done a great job thus far. So this requirement is important, and if it can be met, as appears to be the case, we can hypothesize that the efficacy of refined operational practices will be dependent on two factors. The first one is the relationship between rabbit home range size and flight path spacing, and the second one is the bait density in the treated area. And I'm going to go through both of these, but firstly, if we get back to the schematic of 1 kilometre by 1 kilometre area, so 100 hectares. We'll note in this case that instead of the bait being broadcast, we have strips of bait sown across the landscape. And the first key point we believe is that all rabbit home ranges have to overlap this bait strip. If they fall between it, they may not be able to encounter the bait, and so will likely not be killed during a poisoning operation. The second point relates to the bait density within the treated area. So as I mentioned earlier, current practice sows 30 kgs per hectare, which results in a bait density of about 0.5 baits per square metre. Now, in all of the experimental treatments we've designed, the bait density within the treated area remains at least 0.5 baits per square metre. So this essentially relates to functional response theory. I'm not going to go into this in any detail here. However, it's basically the intake rate of individual rabbits in relation to bait density. And we believe this is key, and there are two factors that are very important here. The first one is that the rabbits need to be able to encounter a strip of bait. All the rabbits have to encounter that strip of bait, and then once that strip is encountered, they have to be able to encounter sufficient baits within the treated area to consume a sufficient quantity of bait to obtain that lethal dose prior to the onset of toxicosis. So in other words, in this work, the functional response is constrained by time of about 20 minutes. So if we go back to this schematic of broadcasting of bait using a fixed-wing aircraft and flying lines at every 25 metres, you'll note that there are about 40 lines per 100 hectares there, so across that 1 kilometre area. If we increase that flight path spacing to say 75 metres, which is the initial distance that we chose to assess, it reduces the number of flight lines from 40 to 13 lines per 100 hectares. So it's quite a significant reduction in the amount of flight time required to get an operation done. I'll go into the costs, relative savings associated with that a little bit later, but in essence that's the theory behind our work. So just to go over some experimental trials that we did last year. First of all, let me point out T1 here. This is just the current practice that I've been explaining recently. So both pre-feeds, toxic and the toxic treatment are all sown at 30 kgs per hectare. They're broadcast, and as I mentioned, there's a flight path spacing of 25 metres required. The next three treatments are all of our experimental ones. They differ very slightly in various variables that we're changing. T2 differs from current practice in that the flight path spacing is increased from 25 metres to 75 metres, and the toxic sowing rate is reduced from 30 to 10 kgs per hectare. T3 differs from T2 in that the second pre-feed is also strip sown, and T4 differs from T3 simply in the fact that the toxic strip width is decreased from 25 metres to 10 metres. And it's that treatment that I'm going to focus on presenting some results of today. And just to note that we did 2 replicates of each of these experimental treatments and 2 replicates of the experimental control, and that experimental control is our current practice. So we did this work in central Otago. We monitored the treatments using 4 800-metre spotlight transects per 100 hectare block. These were walked transects, and the dependent variable we were interested in was the change in the relative abundance of rabbits before and after control. So in other words, the percent kill. And the other important thing to point out here is that I've been talking about fixed wing aircraft, and yet you'll notice that a lot of the photos I've been showing have been using a helicopter. We used a helicopter last year simply because there were no airstrips available to use a fixed wing aircraft, and so we simulated the sowing of baits using a helicopter. We would like to go on and conduct our future trials using a fixed wing aircraft, and that's what we intend to do. However, last year that wasn't available. We don't see why the results should change, but we want to go ahead and assess that anyway. So here's some results from the T4 experimental treatment. On the y-axis we have the reduction in rabbit numbers shown as a percentage. On the x-axis we have 2 replicates from 2 different farms. In the light grey bar we have current practice, and in the darker grey bars we have the T4, which I've just described. And the important thing to note here is that there is no statistical difference in the percent kill between any of the treatments. The bars associated with the graph here are 95% confidence intervals, and they overlap in all cases. So the important take-home message here is that based on our 2011 trials, the experimental treatments were just as effective as the current practice. And if we look at that in terms of savings, T4 cost approximately half what current practice does, so there's reasonably large savings to be made there, and it also reduced the amount of bait, toxic bait and 1080 quite dramatically as well, by about 67%. So the important take-home message is that our experimental treatments, not just T4, which I've shown you the results of, but also T2 and T3, were just as effective as T1 at killing rabbits, and they provide significant savings in terms of the control costs themselves, as well as a reduction in the amount of bait and 1080 used. However, there is an important qualifier that needs to be added there, and that is that we simply need to assess this further. We need to assess it using a fixed wing aircraft, and we need to get further replicates to substantiate 2011's, the results from 2011. So we received funding from Ministry for Primary Industries Sustainable Farming Fund, and we would like to go on and get another additional replicates of the T4 that I've just shown you with a 75-metre flight path spacing. We'd also like to extend that flight path spacing out to 100 metres as well as 125 metres, and then we've got one final replicate that we would like to look at, which in essence has all 3 feeds, both non-toxic pre-feeds and the toxic, all sown at a flight path spacing of 75 metres. We expect to do this work within the next month or so, so it's about to start, and that month would be July and August, I guess, that'll occur over. These treatments that I've just described above will provide savings of up to about 67% for the per hectare control costs, and provide reductions of about 67 to 80% of toxic bait and 1080 use per hectare. So I'll leave it at that for the meantime. I'd like to acknowledge various supporters of this project: Ministry of Science and Innovation for funding, Ministry for Primary Industries for upcoming funding for the 2012, 2013 and 2014 trials, Otago Regional Council for logistical support, they've been great, Helicopters Otago, the landowners involved in the trials, and the Rabbit Coordination Group. And if there are any questions or people would like to contact me about this work, please feel free to do so.